Section 10.2 is called Ideal Transformer with Loose Coupling. So in 10.1, we attempted to account for the imperfect core. So what we're going to look at now is we're going to, assume a perfect core in negligible resistance in the windings and so forth. And we're going to create a model that will account for this imperfect coupling of magnetic flux between the primary and the secondary. So Wilde tells us to consider this transformer in figure 10.3, and its title is Transformer with Infinitely Permeable Core at No Load. So what we're showing here is a source, E sub G, that's connected to the primary side, of course, and it's operating at no load. There's no load on the secondary side out here. And so the voltage across the primary, the induced voltage, this E sub P, it sets up a mutual flux that he defines as this. And this flux, because of this relationship between, voltage and current, the current causes the flux. So the flux itself, is going to lag the voltage by 90 degrees, the voltage being E sub P. And that value of flux is a derivation from an equation that we looked at earlier. And so we're going to actually define a specific flux, and it is defined by this equation that we actually developed back in chapter 9. And because the core is infinitely permeable in this discussion, and because it has no losses, the no load current, this current, is 0. Okay, so there is not that connection that we looked at earlier, with the iron losses and the magnetic hysteresis and all other losses that we had to account for. So that current is 0. So the voltage, E sub 2, over here, it's going to be it's going to be equal, back to this equation, right? This relationship between turns ratio and voltage. And if we solve that for E2, then we're going to get N2 over N1 times E sub 1, or in this case, primary. And so owing to the current being 0, since the current is 0 here, there is no flux available to drive flux through the air. Consequently, there's no leakage flux linking with the primary. Okay, so just for a discussion, just for an understanding, this is where we begin with that. Okay, and that's pretty simple and pretty basic, I think, to understand. Now, this thing is going to get really complicated in a big hurry when we add a load to this relatively simple representation. And so get ready, and we're going to uncover the second part of this, where we couple a load to it. So let me end this video. Make sure you understand, what the conditions are in an unloaded. And now we're going to go to a part 2, where we look at a loaded. The currents start to flow, and the fluxes start to spread, and this thing is going to get complicated in a hurry.